We have made it to the very last lesson in the next to the last module. We're looking at Module 12, Lesson 9, which is covering volume and surface area of composite figures or composite solids. A pacing guide claims this is a one-day lesson, but guys, they're giving us 17 resources to get through here. I don't think it's going to be a one-day lesson. Many families use mailboxes like this one to send and receive mail. The mailbox shown is considered to be a composite object. The term composite means made up of more than one element. Okay, you got the door, you got the sides, you got the base, all that stuff going into it together. What dimensions would you need to know in order to find the volume of that mailbox? Well, these are some of the things we're going to be looking at when we get into this lesson here. Composite solids are defined as objects that are composed of multiple three-dimensional objects or solids. So here you've got this thing that's, I don't know, like a strange looking dumbbell. Almost looks like the thing at the bank that you send them the check through. It's made up of two different things. First thing is going to be the rectangular prism you have here, and the second thing is going to be the two cylinders that you have here. So technically it's three different things, but I think the cylinders are the same size. So we're going to take and figure out that. Yep, that part's good. Next thing we're going to do is say, what is this thing made up of? Well, we have a cone, we have a cylinder, and we have another cone that makes up that. So if we wanted to find the volume of that, we'd have to find the volume of the cylinder and both of the cones. That one's good. Now we're going to check the next one. We have a hemisphere and a cone. The volume of that would be to find the volume of those two pieces and add them up. And then finally, what's next? We have got, ooh, that one's interesting. We have a sphere and we have a cylinder. But that one will be a real challenge, because technically we have the hemisphere sitting on top of the cylinder, so that one would be very interesting to try and work out as well, because you wouldn't be calculating all the sphere or all parts of the cylinder as well. Let's keep moving along here. Volume of composite solids. To find the volume of a composite solid, you decompose the object into solids whose volumes you know how to find. We have an animation here to help us get through that.
Find the volume of the composite solid. To find the composite solid's volume, decompose it into a cone and a cylinder, and then find the volume of each solid separately. First, find the volume of the cone. Begin by writing the formula for the volume of a cone. Substitute the variables with known measurements. The radius of the cone is 12, and the height is 14. Find the value of the power. 12 squared is 144. Then multiply. 1/3 times pi times 144 times 14 equals 672 pi. Next, find the volume of the cylinder. Write the formula for volume of a cylinder. The radius of the cylinder is 12, and the height is 8. Find the value of the power. 12 squared is 144. Then multiply. Pi times 144 times 8 is 1,152 pi. Finally, to find the volume of the composite solid, add the volume of the cone and the volume of the cylinder, and then round to the nearest tenth. So, the volume of the composite solid is the sum of the volume of each solid. 672 pi plus 1,152 pi is 1,824 pi, or about 5,730 3/10 cubic centimeters.
All right, pretty simple. All we're doing is taking what we already know how to do, finding the volume of each one of those pieces parts, and then we add those pieces parts up together. Not that hard, folks. It's just going to be a lot of work. So here we have the same basic thing, they just flipped it over. They have a cylinder and they have a cone, and we have to find the volume of both pieces of that and add it together. First thing they're going to do is they're going to look at finding the volume of a cylinder using volume equals base area times height, where the base area is going to be pi times radius squared. So let's zoom in, well, maybe not that much, and you can take and see what they plugged in. The radius was going to be 4, half the diameter, and the height of our cylinder is also going to end up being 4. That means from there we're going to check that. And the 4 times 4 is 16. 16 times 4 is going to give us 64 pi. So the volume of the cylinder is 64 pi. And we're going to hold on to that and come back to that when after we get the volume of the cone as well. So now we're going to move on to the volume of the cone. The volume of the cone, what did they just do? I think we may have missed something. Yep, I did miss something. Now we're going to scroll down and find the volume of the cylinder. That form is 1/3 times base area times height, also known as 1/3 times pi radius squared times height. Plugging in what we know. This time the height of the cone is going to be 5. The radius is going to be the same. And from here we can take and say that 4 times 4 is 16. 16 times 5 is going to be 80, and that's where the 80 over 3 pi came from. So now at that point we have the volume of the cone is 80 over 3, the volume of the cylinder was 64, and we're going to add those together. You can see that's happening right here. 64 over 3 64 pi plus 83 pi, and they just made some very strange voodoo here. Okay, let me tell you what they did. Right here they said 64 over 1. They found their least common denominator, which is 3, and then they said, well, 3 times 64, that's going to be 180. 192 plus 80 is how they got the 272 over 3. You with me? Now we can say there that the 272 over 3, that is going to simplify into 90 2/3, I believe, if I just did that math in my head right. Rounded to the nearest tenth, that would be 90.7. Let's see if I did it right in my head. I did not do it right in my head. So now we get to actually take a calculator and do it. We've got, find my calculator, 272 divided by 3. That's going to equal to 90.6 repeating, which rounded to the nearest tenth is 90. You know what I didn't do? I didn't multiply it times pi. That's it. Times pi is equal to nearest tenth 284.8. So I have 284.8. Check it, and now it checks. So the volume of the entire thing is going to be approximately 284.8 cubic centimeters. Do you remember that mailbox we worked on earlier? There she is, only now they're calling it a storage chest. Technically, this is supposed to be your problem. I am not going to make this your problem because this one is a booger, folks. The hard part is finding out that semi-cylinder or half cylinder on the top. So let us take, and I'm going to do a screenshot of this, and we are going to work it all out together, okay? First thing I'm going to work on is my rectangular prism, and the part of the rectangular prism I'm going to work on is what I have boxed in here, the base, to find the base area. So the base is going to equal to 25 times 50, which means the base area is going to equal to, let's see here, 25 times 5, that's going to equal to 125, and put a 0 on the end, so now I have 1250. That's going to be the base area. Plug that in for our volume. Volume is equal to 1250 times the height of 30. Multiply that out. I'm going to have a 0 on the end. 3 times 0 is 0. 3 times 5 is 15. Carry the 1. That's going to be 6, 7, and a 3. So the volume of this whole rectangular base is going to be 37,500. Now, just before I get too deep in, I'm going to verify that because I've been working numbers all day and my head is really starting to hurt. I think this is the 9th video I have made today. So that's going to be 30, and we got 37,500. Very good. Let's keep moving here. Now the next thing I have to do is find the volume of this bread loaf top you see here, where we're going to have to figure out what is going on with each of these pieces. Now what you have is half of a cylinder cut lengthwise or height-wise on that cylinder. If you take a close look here, let me take and get some color here, you can see the base is going to be half a circle. So I'm going to do a formula for area of a circle for my base, which is pi times radius squared, and I'm going to divide that by 2. Good so far? Let's start plugging in values. Base area therefore is going to equal to pi times the radius is half of 25, which would be 12.5, and we're going to square that, divide it by 2. Base area is going to equal to, let's grab our calculator here, 12.5 times 12.5, that's going to be 156.25, so pi times 156.25 divided by 2. And now when I take and divide that by 2, divided by 2, that's going to give me 78.125. 78.125 pi's is going to equal to my base area. And I'm just going to leave it like that. I'm not going to multiply by 3.14 yet. Now I've got to multiply that times the height of the cylinder. And this distance right here, that is the height of the cylinder, folks. Okay, so I'm going to come back over here, plug it in. Volume is equal to, my base area was going to be 78.125 pi's times the height, which is this distance here, which is going to be 50. We're going to grab our calculator and type that in. So I already have the 78.125 times, hit my pi button, times the 50, and now I have the volume of that piece of it is going to be 12,271.8 rounded to the nearest 10. So volume is equal to 12,200, look at that again, 71.8 to the nearest 10. And we're going to circle that. Now all that's left is to add that information together. So we're going to take the two totals we came up with here. One of them is 3,000. Let's change our color so we can see what we're doing here. One of them is 37,500 for the rectangular prism. The other one is going to be 12,271.8. And we're going to add those two things together. We're going to annex in a 0 right here. Add these up. 8, 1, 7, 7, 9, and 4. There's our decimal. So our final answer should be 49,771.8. Let's jump over to here. Type it in. 49,771.8. Check it. And it checks. Easy math. That's going to be it for video number 1 of this lesson. Come back for video number 2, where I hope to finish this all in one more video, but I'm not entirely holding my breath on this one. But we are almost done with module 12, and then we just have one module left to go.